Hello, I'm going to talk about the introduction to large language models, which is part of the Generative AI course. So what are the large language models? They are trained to solve common language problems like the text classification, question answering, document summarization, and then the text generation. So how do you go in depth and understand the large language models? So why it is large? Because the training data set is huge that you cannot even imagine what is the size of the training data set. It also has the parameters which defines these data sets, which is large, huge, in terms of billions of parameters. The general purpose here is that commonality of the human languages. And then we also have the resource restrictions in accessing those contents. So these large language models are so popular because they are all pre-trained models. So many of them are something like you can take it off the shelf and then start using it immediately, provided you have enough computing resources. So you can do many tasks as mentioned on the right side. You can do the language translation, sentence completion, text classification, question answering, and many more. So what is the core of your large language models? As I told you, they are pre-trained transformer models. So how does it work is that you give a particular sentence in a language as an input, and the transformer reads that into a component called encoding component and sends it to the decoding component to translate into the destination language. So you can see here a language which we do not know what is that as an input, and the output is in terms of English. So why these large language models are so popular and so productive when you compare with the traditional development? So the large language models, which are used as a pre-trained APIs in many of the applications, do not require any machine language expertise, do not require any training examples, no need to train a model once again. For example, you download the model and then retrain it, that is not required. It thinks about, the user who is going to use have to think only about how to design a prompt to get the works done through this LLM. Against the traditional machine language development, which says that you always require machine language expertise to understand what the model is all about. And of course, when you have the model, you need to retrain them with your own examples. This also needs to train a model which you have downloaded or reusing. You also require a huge computing time on the hardware. So the user, when they want to use, they have to think about minimizing a loss function, and that absolutely requires the understanding of the model. Let's take the question answering, which requires the domain knowledge, right? So for example, if you have a big tech company, you provide tech support to customers, right? So you can always deploy this as a customer service to a technical company. And for the consumer, you can provide tailored messaging to individual customers or the consumers in terms of individual emails, individual messages. And on the education side, it provides information on courses, tuition, and policy. Media, you can provide information on subscriptions and services. And on the pharma and healthcare, provide information for patient self-management. For example, a record of a particular patient and the complete details, right? If you feed it into the LLM, it can actually analyze about the patient and it can give you the results depending on the queries that you pass. And of course, on the retail side, provide better chatbots and product visualization. And on the supply chain side, provides logistics information on inventory information. So these are all very limited number of applications, but the domains where it can be applied are huge, and it is getting expanded day by day. So what is important when you start using LLM is how to design the prompt. So it's a process of creating a prompt that is tailored to the specific task that the system is being asked to perform. So there's a new terminology which has emerged called prompt engineering, which is a process of creating a prompt that is designed to improve the performance. So when you look at the generic or raw language models, which is usually for predicting the next word technically, which is called as token, based on the language in the training data. We also have dialogue tuned, trained to have a dialogue by predicting the next response. So that's what you see that in most of your email replies. So the moment you start writing the emails, it predicts what could be the next word or the sentence. And we also have the instruction tuned, trained to predict a response to the instructions given in the input. So you need to set the context by giving the instructions to the large language model so that it works based on your instructions, right? So when you look at the generic language model, how the next word is predicted. For example, we have a sentence, the cat sat on. What's next? So how the LLM does is that for each of these words, there's a vector representation which is called as the input token. That's fed into the LLM, and the token is part of a word, the atomic unit that LLM works on. We have the next words which are predicted based on the vector representation for the next output token. So there are a lot of possibilities, like most likely the next word could be the, and next most likely could be a. So then it actually puts all those predictable, the words according to the vector representation and the ranking. So the words which are coming below are less likely to be the next words, right? The example for the instruction tuned language model is the prompting, as I said. For example, I summarize a text of, I give a paragraph, or I give a Word document, I give anything, and then generate a poem in the style of X. So I say that this is the style I want, create a poem. Give me a list of keywords based on semantic similarity for whatever it is. So that's the input given to the large language models. Now the output is either summarization, writing, or keyword extraction. And the dialogue tuned language models, so they are the special cases of instruction tuned where requests are typically framed as a question to a chatbot. Dialogue tuning is a further specialization of instruction tuning that is expected to be in the context of a longer back and forth conversation, and it typically works better with natural questions like phrasing. So I have, for example, I have certain policies. I feed the policies into the chatbot, and I request the chatbot to give me the answer based on the policies, right? The questions need not be a very formal questions. It can be more of a natural language question, which any consumer may have on that policy, right? So we also have chain of thought reasoning. The model is less likely to get the correct answer directly. So it has to go on a chain instead of just one just solid questions. So question is something like this: Roger has 5 tennis balls, he buys 2 more, etc., etc. The answer could be, let's think this through step by step. So that's the chain of thought reasoning. So here the models are better at getting the right answer when they first output the text that explains the reason for the answer. So now the output is more likely to end with the correct answer. Something like this: Roger started with 5 balls and 2 cans of 3 tennis balls, each is 6 tennis balls. Now it gives me the reasoning, the answer. So that's the chain of thought. Thank you for watching.